is mock TMUA set D, paper number 1, again by Jacqueline Tyler. So thank you so much to her for writing this. I'll put her website in the thing below. You can get some more papers there, and you can also ask to contact her for tutoring, things like that. Anyway, we'll do questions as always. So question number 1, this does actually factorize into like 2x plus 1x plus 5, and then you could put the solutions to that, so like minus half and minus 5 into here, just like factor theorem normally, and you end up with a simultaneous equation in A and B. It's not the easiest way of doing this. The easiest way is to simply say, well, this, if it's a factor, this times some linear thing, like px plus q, must equal this. But of course, we can expand this really easily, because of course, and we can even group things, right? So obviously 2px cubed here, then the x squareds come from doing 2q and 11p. So that's just right there, and then the x's come from doing 5p and 11q, so that's there, and so on. And now we can just compare this to this. So 2p must be a, we don't have any information there, so that's fine. This must equal minus 17, this must be b, and this must be minus 15. And this is actually much faster because q, of course, is minus 3, which we can then put into, I guess, this one. It doesn't, yeah, this one next, right? Which makes p minus 1. We can then put both of these things into here, or we can put p into here. Doesn't really matter. And we'll get a and b, and then we can add those together, and we'll have the answer of a as our first one. All right, so we split this fraction up in half, so it's this thing minus this thing, just a very standard trick. Cancel those and write that as a power minus 3, and we integrate, because of course you differentiate to get to dy by dx, so you integrate to get to y. This integrates like this. Don't forget the plus c, throw in minus 1, and yeah, I mean, minus 1 to an even power, even if it's negative, is plus 1. So that's just going to be fine. We solve that c is 1, and this is the only one that makes any sense. So we'll go with it, and a very standard question that. A radius a circle radius 1 is inside an equilateral triangle like this. Now, what's the area of the triangle? Well, we can break this up into thirds, right? Into sort of 3 kites. Here's a kite. There'll be another kite up here and another kite down there. If we cut this in half, I mean, we know that imagining those 3 kites, it's 120, 120, 120 degrees. So if we put a line down here, that's going to be 60 degrees there. And that's really helpful because this length here is just the opposite, and this is the adjacent, because there's a right angle here, of course, tangents and radiuses. So I think tan 60 is this over this, right? I think, where this I'll just call x. So therefore x is just root 3 because tan 60 is root 3. Now, of course, the area of this triangle here is just a half times root 3 times 1, which is root 3 over 2. But then there's 2 of them, right? So this whole thing will just be root 3. And then I've got 3 of those kites in total to make 3 root 3 as the answer. Both of these inequalities then, so this factorizes because most things in TMUA should. We're less than 0 and it's a positive quadratic, so we need to be in between the roots. So that's going to be from minus 2 to plus 3. And then here, of course, we can just solve this. I tend to move the 3x over rather than timesing or dividing by a negative. I don't really know why, but that's just what I tend to do. X is less than 1, so we're between minus 2 and 1. And now we're in between 2 roots, so we sort of want a positive quadratic that's maybe less than 0, just like this one was to get this kind of thing, and we want it to have roots minus 2 and 1. So just make the quadratic that does that, and when you expand it out, you get the first one there, and I think that's all going to be good to go. So a cylinder has a normal volume of pi r squared h. Now r is going to become 0.8r, and we need to make h something else to compensate. So I'll just call it xh, where x is like the decimal that should go in front of it, and the volumes now need to be the same, because it says so. So the old pi r squared h needs to equal this with the 2 adjustments. Now this squared is 0.64, all of the letters will just cancel. So now we can just find x here by doing 1 divided by 0.64. There's a couple of ways you can do this. I times everything by 100, and then I just got out a bus stop. I didn't do this in PowerPoint because I couldn't be bothered. But dividing by 64, you can just divide by... I mean, you could just keep halving a whole ton of times, or you can divide by 8 in a bus stop and then divide by 8 again, which I thought was a tiny bit more efficient, but it doesn't really matter. You end up with this eventually. Again, writing PowerPoints writing bus stops in PowerPoint is really annoying. But anyway, from this decimal, it's clearly a 56.25% increase because that's what this decimal does. So I think we're good to go. Arithmetic progression and also this one, geometric's first time 1. So arithmetic progression goes 1, 1 plus d, 1 plus 2d, and the geometric goes 1, 1r, 1r squared, or just r squared. So that's cool. The sum of the second terms, so that's this one plus this one, equals 5/4. So we'll write that, and the sum of the third terms is this plus this. Now, you want to kind of get rid of one of these two letters. It's just a simultaneous equation, right? So I think I also got rid of these fractions because I didn't like them. So I times this one by 4 and then times this one by 2. That doesn't quite get rid of the fractions, but I think I will in a second when I do this, take away this. Then I'll double everything again and move some stuff over. And now this factorizes because it's TMUA. And so you get answers of this and this. Now this is not allowed because that would make a non-convergent progression. So r is a half, which means the sum to infinity is a over 1 minus r, where a is 1, as it said before, and r is a half. So it's just 1 over 1 minus half, which is 2, I believe, for our answer. We do cos inverse of both sides here. Now, cos inverse of a half is, well, it's pi over 3, right? Because it's coming down from 1. So it's pi over 3, but also minus pi over 3 because it's symmetrical all the time, right? But then it also equals a half when you go way over to the other side of like 2 pi minus pi over 3, which is 5 over pi over 3, and then again there's a minus as well. And then you keep getting solutions later on. Now, the issue with all these is that sine of x is between minus 1 and 1. And even the smallest of these solutions, pi over 3 is slightly bigger than 1. So there are no solutions. All of these numbers are bigger than 1. So I don't think there's any solutions there at all. And I think that's all we need to say. We've done questions like this before with mods. We treat the areas differently. Over here, x is positive and y is positive. So neither of these two mods are doing anything at all. So we're just going to draw a graph 2x plus y equals 2. Now, of course, we can rearrange that if we want to, or we can do the cover-up method you may have been taught, like when x is 0, y is 2, clearly, and when y is 0, x is 1. So it goes through 2 and 1 like this, or you can rearrange and draw a line. It doesn't really matter. Now, I think I'm not going to bother doing the rest of this. I think it's pretty clear that it's going to be symmetrical and make like a diamondy shape here, but all that matters is the area, and that's going to be 4 lots of this triangle. So this triangle is a half times 2 times 1, which is 1, and then just times it by 4, and we'll end up with 4. But you can draw all this yourself. But again, if you're doing TMUA, you probably want to be finding some speedy ways of doing things. The minimum value of this function is when this function on the bottom, sorry, the maximum value of this function is when this function on the bottom is at its minimum. So we're looking for the minimum of this. Now, this is just a standard indices kind of quadratic question where 9 needs to be written as 3 squared, and then you swap the x and the 2 over to get 3 to the x then squared. I mean, the line between here is 3 squared, 4 to the power x, and then just swap the x and the 2 because they're multiplying, so it doesn't matter. And this is just a quadratic, right? I just chose to complete the square immediately. In my head, I had this as like just a big x, and this is an x, and then just complete the square like this, which is this. And so its minimum is 2, which means the maximum of this happens when this is 2, which is a half. And we're all done here for question number 9. Question number 10 then. So how do we get these minus 2x's in? Well, if you made this into an x minus 1 all squared, which is of course a movement of right 1, because it goes the wrong way, remember, then when you expand this out, you would get a minus 2x. So that's good. And then, of course, I will expand this out, and I'll get this. And, of course, to get from here to here, I think I need to move up 3. So I think that's answer C. And yeah, that's I think all there is to it. You could also just think about the turning points of these two things, like this turning point is 0, 4, and this turning point, if you complete the square, is minus 1, minus 3, as we said. So, like, think how you get from one turning point to the other, and you're pretty much done. Question 11, then. This is a really nice question. I think I maybe put too much work into this. Maybe there's a quick way of doing it. I'm not sure. I first said that 4x squared is the same as 2x all squared because I was thinking that I could get this 2 to the front and it would slightly ease up some of the workload here. I also expanded out the square here, so 2 squared is 4, and then this just becomes squared. Now, I couldn't see an easy way of getting this 4 into a 2, although I can see an easier way now as soon as I'm looking at it. Yeah, this 2 came down to make an 18. And then I chose to just split the log into 2 plus x here, because these two things were times to make this. I guess I could have written this as 2 there and 2x there, and I could have saved myself expanding this out, but it's not going to matter in the end. It will be the same thing, but maybe that's slightly faster. Anyway, log space 2 of 2 is 1, and log space 2 of 4 is 2. So then it just becomes a case of expanding this out, doing some rearranging, and it's just a quadratic. I just wrote L's for the logs, which means log is either 1, log space 2 of x is either 1, which of course means x is 2, or log space 2 of x is minus a half, which is a thing we can do. It's 2 to the power minus a half, which is 1 over 2 rooted, which is 1 over root 2. And then we just need to add up these two solutions together. And yeah, it's not too easy. Well, it is easy at this point, right? Times by root 2 of root 2. And then I think if you times over by root 2 again, you get to this one here by a bit of rationalization. Question 12, not an easy question here. It's one of those congruent triangle-like questions. So the two ways that they're asking you that, or telling you this triangle could be drawn as, is either this, where AB is this, BC is this, and angle BAC is that. But of course, imagine putting a compass at this point with length 2a, then you could sort of swing it around a circle, centered at this point, and it would hit this line down here, both here and back here, and it would make it look like this, like because you're imagining an arc like going around like this, I guess, and it would go through there. So those are the two triangles that you can sort of draw. Now, this triangle is essentially 3 times bigger than this one. So if I draw this one inside of it, this area is half this area, because it goes sort of, now it goes 1 to 2 in ratio to make the whole thing 3, and this just a 1. Except I can split, because this side here is also length 2a, because of this, of course. This is an isosceles triangle. I know it doesn't look like one at all, but that's because my drawing is just terrible. This is definitely isosceles, which means I can cut it down the middle and make a right angle. And again, the picture is terrible, but the logic of this all holds. Now, the next thing we can say is that the height of this triangle perpendicular to the base, I'll just call h. And of course, if all these triangles are equal, which they are, because remember, this is ratio 1 to 2, and I've cut this area in half to get this, so this is now ratio 1 to 1 to 1. So all these triangles are equal in area, which means they all have the same perpendicular height from here to here, which is actually this height here, although it doesn't look like it, again, because that doesn't look like a right angle, but it is just this length here. That means all these bases are length x. They're all the same, because of course the area of this triangle could be written as a half times x times its perpendicular height, which was h, and likewise here, half times x times h, and half times x times h. So all these are x, which means that I can say some nice things about x and a by doing a bit of Pythagoras, because I think I can say that if this is h, as we've said before, then root 7a squared, which is 7a squared, is equal to h squared plus 2x all squared, which is 4x squared. Where did that 4 go? That's annoying. Where did that 4 go? Oh, sorry, this is the other triangle. This is the other triangle you can do Pythagoras on. This is this triangle. That's 2a all squared, which is 4a squared, equals h squared plus x squared, a single x squared here. And now, yeah, I remember here. Now I did this one take away this one, so that makes 3x squareds here and 3a squareds there, which means x is just equal to a. So after all of that, I can just replace these with a's, and I can also say cos theta is going to be, well, this is a right angle triangle, remember, so it's just cos theta is 2a, which is all of this, divided by root 7a, and the a's cancel, and you get 2 over root 7, which is answer A. Quite a difficult question, but also quite an interesting and fun one. Got 2 circles here, which are center 12, 0, and center minus 13, 0. Radius is 6 and 9, so maybe a bit like this, I guess. And we want a line which is tangent to both of them. Now, there's 2 ways you could do that, really. There's either this line, or there's a line running along the top like that. And it wants to get the shortest line segment between intersections. Now, that looks like it's going to be this one, but we should probably do some maths to make sure. So, okay, well, we've got radiuses of 9 and 6, as we said before. A really nice Pythagoras trick here that's worth knowing. This distance here, by the way, is 25, because it's distance from 12 to 13, or sorry, from 12 to minus 13 is distance 25. And now the nice Pythagoras trick you can do here is move this 9 down to here, and then say that the distance that we want, which is this distance here from intersect to intersect, is the same as this distance here. And now I can just do Pythagoras on 25 squared minus 15 squared. And you might just recognize a bigger version of the 3, 4, 5 triangle. So I believe this is just going to be 20, which means this distance here is 20, which is one of the answers, which is good. Now we should probably just get rid of this case. And the way we can do that is we can draw this 25 across like this, and then claim that this distance here is 3, because these two things are parallel, I think, because these are both 90s here to get to the tangent here. So that's, I think, up there 3, and then 25 squared is 65, minus 3 squared is 616, which is this answer, which is bigger than 20 squared, which is 400. So 20 was the correct one to minimize that. When we expand this, we get something that looks a bit like this. 60 is this, and to be divisible by 60, therefore, we need our terms to have at least 2 2's, at least 1 3 and at least 1 5. Now this term doesn't have a 3 or a 5, so that's not going to be divisible by 60. This term, 9 choose 1 is just 9, which is essentially just 2 3s. So it has the 3s, it has the 5s from here, and it has enough by far 2s from here. So this term is definitely divisible by 60 because it has all the right primes. Now this here, and sorry, this should say a 3, apologies. Now this here is, we don't have to work this out, right? We can just say that the 9 from the 9 factorial is not going to cancel with anything, so therefore this has a couple of 3's in it. And likewise, 9 choose 3, which is what this should say, also still has that 9 from the 9 factorial in the top. So that's definitely going to have enough 3's in it as well. And then we can make the same argument, this has enough 5s, this has enough 5s, and this has enough 2's. I just completely wrote this term wrong, because that should be a 6, right? And that should be a 3. And then I somehow remembered to change that term, but not. I was doing a lot of copying and pasting, as you can imagine. I don't know how I messed it up so badly. So anyway, this will be fine, this will be fine, this will be fine. It'll be fine all the way until the end, when we get to some more terms over here. Now this won't be okay because it doesn't have any 2's. This won't be okay because it doesn't have enough 2's. But back here, we will probably be okay because, again, there's still nothing up here to cancel the 9. So that'll have enough 3's. That has enough 2's and that has enough 5's easily. So this will be fine. So I think everything will work except for this term, this term, and this term. When you expand something out, the number of terms is always 1 more than the power, and you can verify that just thinking about smaller expansions. So there should be 10 terms here, and we know all but 3 of them work, so I think 7 will therefore be the answer. Now we want this whole thing here to be negative in this range, so therefore we need either this to be negative and this to be positive, or vice versa. So okay, let's deal with this case first, and we need them both to be true. So we'll solve this. Of course, sine x needs to be greater than a half here. This is the other case we'll do later. Greater than because we have to either times or divide by minus 1 or move the sine x over. And here, of course, this is whatever. So sine x is pi over 6 or 5 pi over 6. And we want to be greater than a half. Draw the sine graph in your head and say that we want to be bigger than a half, so we need to be between these two values. Here, again, draw cos of 2x in your head. It's just the cos graph, but squashed factor 2. So it's going to do the whole cos thing twice up to 2 pi. Now, cos equals 0 at pi over 4 usually. Sorry, at pi over 2 usually. But it's squashed, so it'll be at pi over 4. So it'll be bigger than a half between 0 and pi over 4. And then you can say, again, cos equals 0 normally at 3 pi over 2, but it's squashed, so it'll be 3 pi over 4. And then again, on the other side, because we're going to have to keep going because the cos graph is going to do this whole thing twice, this would have been easier if I had drawn the whole thing out, but I was testing myself to see if I could do it in my head. The next one is 5 pi over 2, but again, squashed, so it's 5 pi over 4, and we'll need to be in between those, and the last one is here. And we need to cross-reference when those two things happen at the same time. So pi over 6 is smaller than pi over 4, so there's a little width between pi over 6 and pi over 4 where both of these, where both of these two things are true, so that will be our first range. And then we can go over to here. 5 pi over 6 is bigger than 3 pi over 4. So again, there's a little range between 3 pi over 4 and 5 pi over 6. 5 pi over 4 is too big, where we are the thing again. So these are the ranges up to 2 pi. And anything beyond this is pointless because this one isn't true. So all of this is pointless. Now here, I obviously made the denominators the same. There's a 1/12 pi interval here where this is true. But of course, that's over just a single pi. So I'll divide that by 2 to find the kind of proportion up to 2 pi for which this is happening. I probably should have done some more writing down here, but I was kind of in TMUA mode of just like, this is what I would do if I was doing this myself in the exam. But again, maybe to clarify that, there's a width of 1/12 pi in here. The width is 1/12 pi, and 1/12 pi over 2 pi, which is the whole thing, the pi's cancel, and it's just 1/24th, right? So that's the width that counts here. Now here, the same thing, make the denominators the same, and there's a 1/12 pi again, so that's going to be another 1/24th of the entire band. So that's going to be a 1/12 for this case. Now the other case, this is much quicker, because if we've already found when this is true in the exact opposite region, so up from 0 to pi over 6, and 5 pi over 6 to 2 pi. And likewise here, just the exact opposite to this, so that's going to be between these two and between those two. Again, some cross-referencing. So pi over 6 is less than pi over 4, so there's nothing happening here. Pi over 4 up to 5 pi over 6, 3 pi over 4 is less than 5 pi over 6. So I think this whole region here just kind of just doesn't work at all, because this is bigger than this, so it's outside of this one's, and this is less than this, so it's outside of this one's as well, so that doesn't work at all. However, because this is bigger than this, all of this works up to 2 pi. So I think we just need all of this. So this is the final thing we want. Again, I mean, the denominator already works. This is just a 2 pi over 4 band, which of course then gets divided by 2 pi again to make a pi over 4 band, or just 1/4 of the whole region. 1/4 plus 1/12 will give us 1/3 of the entire thing, is correct. Yeah, some drawing of the graphs would have helped there. Speaking of drawing of graphs, this is a very standard question, and it just involves drawing this, because otherwise this question is just not really doable. So firstly, we know it has a winds up to -5. We can differentiate this. Again, the thing that makes this question work is the fact that there's no x term, because when you differentiate and set to 0, this now becomes a cubic that's easy to solve, because there's no constant term here that would have come from deriving the x term. So factorize out the x and also just divide everything by 12, and then factorize this, and you get turning point at 0, which means I can draw a line through here because I know that's the turning point at 3 and at 1. Now at 1, it's easy to work out where this graph is. It's 3 minus 16 plus 18 minus 5, which is 0. So this has a turning point there at 1, 0. And now, because this is a quartic graph, it must start up here, it must end up here, which means it must go through like this, and then I don't need to bother putting 3 in here. Because I know it turns here and I know it turns there, I guess this could be an inflection point, but I think if it were, this would probably have to appear twice. And also, the picture just doesn't make any sense, because then I need to inflect here and maybe also inflect here, which I don't think is allowed in quartics at all. So I think putting in 3 must put it down here, and the graph must kind of go through like this, and I'll have 1 when it passes here, 2 when it goes up to there, and then 3 when it comes back up here again, roots in total. Maybe if you want to be safe, you put 3 in, but again, I was doing this as if I was doing a real time paper, and not bothering with nonsense maths like trying to work out what happens when you actually put 3 in here, because I couldn't be bothered to do that at all. Nice indices question here. It's tempting to immediately convert these all to 2s, but I think the easier thing to do first is just double all of this, like this. And then I can just do this, take away this, or vice versa, to get an equation in y alone. And now I converted it to power. No, I didn't even convert it to power 2s, because it's already in the form I need it to. This is just 4y all squared, because these times together to make this. So now it's just immediately a quadratic, with solutions at either this is 0 or this is 2. Of course, this is 0 doesn't really have any solutions. This is 2 does. Y equals a half, which means going back a second up to like here. Well, if 4 to the y is 2, then that means I can just put a 2 here and get this. And now maybe you just recognize here x needs to be 3 over 2 to make that work, because you'd root the 4 to a 2 and then you cube it to make an 8. So add these together, and I think we end up with 2 as our answer. F of x is this thing here. F of kx is just what happens when you replace x with kx every time. So it's kx all squared, which is k squared x squared, and kx there. And now I can find the turning point or minimum point of this just by completing the square, because I can, and I think I'm quite good at completing the square, which is why I was able to do this quite quickly. But clearly I just need a kx here to make the k squared x squared. And then I don't need a k here, because this just times this to make minus 2 kx when I have the 2 brackets, which doubles, of course, to make this. And then just take away the 4 from here. And now this turns to this. So the turning point is at 2 over k, comma, minus 2. Again, swap the sign as usual. Now over here, we just need to replace x with c minus x, and then I expand all this out. I guess I probably could have completed the square on that straight away, but nah. Expand it all out, and then just write it up nice and simply, and then just halve the thing in front of the x, which is actually a 2c plus 4, so just halve all that down to make this. I kind of just expanded this out in my head to check that it all worked. Like when you expand this out, you get a random plus c squared term. So I had a minus there, you get a random plus 4 term, so I get a minus 4, and then you get 2 minus 2c terms from expanding this out. So just get rid of those with a plus 4c. And now the turning point here is negative all this, so it's going to be c minus 2. And then, of course, all of that. Now, it has the same minimum point, which means 2 over k must equal c minus 2, and just flip them both over, and then times by 2, and you end up with this one here. I guess you can actually solve for c, because this must equal 2, but I couldn't be bothered. So, yeah, wasn't part of the question. 19, this is a circle radius 1. Now, I forgot to look up the name of this. In Decision somewhere, there's a thing where you use a line and you kind of drag it up the picture, and I can't remember the name of the line. Someone can tell us in the comments and teach us or something. But there's a thing in Decision that you do for that. I can't remember it. Anyway, greatest possible value. So just call this k and just turn it into a line, right? So you can rearrange for y if you want to, and then you can say, well, k is essentially just the y-intercept, sort of. So to maximize k, you want this line to be as high as possible, whilst still, meeting this requirement. And the highest you can put that line is here, because then at this point here, x squared plus y squared is still equal to 1, and it's on this line. So therefore, we can just say, therefore, we have the maximum k, because k is the intercept. So this is the setup we need. Of course, finding this coordinate will be super helpful, and we can do that because this gradient is minus 2/3, which means the radius has gradient 3/2. Now, if I get out a triangle here of 3 and 2, this radius is root 13, of course. But I know this radius is 1, so if I just divide these two things by root 13, I'll have the triangle that I need. So that's nice. So this coordinate here is 2 over root 13, comma 3 over root 13. And I can just put those coordinates into this here to find the value of k, and I think I'll end up with 13 over root 13, which of course cancels just to root 13, and it'll be done. I think TMUA have asked basically that question before in the past, so yeah, it's a good question to do. Now, this is an exponential function, and a is positive, so this is a strictly increasing function. So its absolute biggest value is when sine is at its biggest, and its smallest value is when sine is at its smallest. So sine is at its biggest at 1, so the biggest f of x can be is just 2a to the power 1, which is 2a. And the smallest this can be is sine x to the power minus 1, which is 1 over 2a. Now the difference between those things is apparently 4, so this minus this is 4. And of course we can times everything by 2 and times everything by a, and we'll end up with this, and we can solve this very easily for a. It actually doesn't factorize, but with these answers, maybe you're not expecting it to. I completed the square once again, just because I feel like I'm very good at completing the square after having taught so much of it in the past. It becomes this, and then of course the sum of the answers, the roots will just cancel, so it will just be 1 plus 1, which is 2. Thank you again for Jacqueline for writing that paper. It was super fun, and I'll do the other paper from this set at some point soon, I guess.